Good morning, learners. I am Latika, your trainer. Today, we're going to learn about the scientific concept behind the STEM at home activity that we did of creating musical bagpipes with the help of waste products at home. Okay, and I'm sure you had a lot of fun creating it. I also made a similar instrument. Today, we'll see how it works and what are the scientific principles behind it. So what exactly is a membranophone? This instrument that we made is a membranophone. Why? So this instrument makes or produces sound with the help of vibrations of stretched skin, in this case, a stretched balloon or membranes. There are a few examples that you can see on your screen, one of which is a drum, the other is a gong, and the third is a tambourine. So gongs are hit with a hammer-like object called a mallet. These are also made up of metal, but in this case, we're studying about stretched skins. So what happens in this particular instrument? So I'm sure you remember what we made this out of: a straw, rubber band, a balloon, plastic bottle, and a sketch pen that you made 2 holes here. Okay, so what happens when you blow the air inside from the straw? It creates pressure on the inner walls of the plastic bottle and on the outer walls of the sketch pen. And also, ma'am told that you should make sure that the sketch pen touches the membrane or the balloon. You'll understand this in just a minute. So when you blow air inside, pressure is created. So what happens is this instrument tries to release pressure. And how does this happen? Once there's too much pressure inside, the membrane rises up. The balloon rises up and there's a space left. So the air tries to escape out from this pipe. There's an opening at the end of this pipe. So it tries to come in and escape out through this pipe. So this is how pressure plays an important role in this instrument. The other thing is vibratory motion. I'm sure we've learned about vibratory motion. The to and fro motion of an object is also called an oscillatory motion or a vibratory motion, which produces sound. In this instrument, sound is produced by this particular method. Vibrations are used to produce sound. What happens is when the air is released out, the pressure is relieved, the membrane comes back to its original position. So you cannot see major change in rise and fall of the membrane. You'll be able to feel it when you touch it. So once you blow the air in, you'll be able to feel the vibrations on the membrane. If you put your hand on it, on the balloon, you'll be able to feel it. So once you blow the air continuously, so this keeps happening. So that is how the sound is produced. When it keeps happening, the pressure comes up, goes up, comes down, goes up, comes down. It causes the balloon to rise and fall, and the air to escape out through this pipe, which helps in producing sound. The third of which is pitch. We know that 2 important properties of sound are amplitude and frequency. Loudness of a sound depends on its amplitude, and pitch of a sound, it depends on its frequency. So we have read about this in our previous chapters, in the sound chapter. So now we know when the frequency of vibration is higher, the pitch will be high, and when the frequency of vibration is lower, so the pitch will be low. In this particular instrument also, we can change the pitch. How can we do that? We can cut the pipe, and since you can see there are 2 holes, I can cut this down to 1. So the sound produced will be different. So now when I blow the horn, you see there's a sound. If I if I put my finger on the other, there's a difference in sound. So that can also be changed. That means we're changing the pitch of the instrument. So these are the 3 main concepts that we've used in this particular experiment. One of it is pressure, the other is production of sound using vibration, and the third is pitch of the sound. I hope you understood this, and if you've not yet made it, take time out to make it and have fun with science. Thank you.